Welcome to our mathematics session, Triangles. We should study triangles since it has a major role to solve many life problems. And it is applicable in various fields such as engineering, astrology, architecture, etc. We see around us monuments, pyramids, buildings, bridges in the shape of triangles. A triangle is a closed figure formed by three intersecting lines. It has three sides, three angles and three vertices. Now we are going to discuss some properties of triangles. The sum of the interior angles of a triangle is 180 degree. That is, the three angles in any triangle always add up to make a total of 180 degree. The angles opposite to equal sides of a triangle are equal. If angle A is equal to angle B implies the sides opposite to these equal angles BC is equal to AC. And also the converse statement is true. The sides opposite to equal angles of a triangle are equal. If the side BC is equal to AC implies the angles opposite to these equal sides angle A is equal to angle B. The angle opposite to the longest side is larger. QR is the larger side, implies angle P is a greater angle. And also the converse statement is true. The side opposite to the larger angle is longer. Angle P is a greater angle, implies QR is a longer side. Sum of any two sides of a triangle is greater than the third side. Example, in this triangle AB plus BC is greater than the third side AC. Triangles are classified based on their sides and based on angles. Based on sides, they are classified as scalene triangle, isosceles triangle and equilateral triangle. In scalene triangle, length of all sides are of different measures. In isosceles triangle, length of any two sides of a triangle are equal. In equilateral triangle, length of all sides are equal. Based on angles, they are classified as acute angle triangle, right angle triangle, obtuse angle triangle. In acute angle triangle, each angle is less than 90 degree. In right angle triangle, one of the angle is equal to 90 degree. In obtuse angle triangle, one angle is greater than 90 degree. Now we are going to discuss about congruent figures. Two figures are said to be congruent if they have the same shape and the same size. Rules for congruency of triangles. In Sss Congruence Rule, if three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. In Asa Congruence Rule, two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. In Rhs Congruence Rule, if in two right triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. In Sas Congruence Rule, two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. Asa Congruence Rule could also be stated as Aas Congruence Rule, as two triangles are congruent any two pairs of angles and one pair of corresponding side are equal. Since by angle sum property, if two pairs of angles are equal, then the third pair of angle is also equal. But Sas Congruence Rule could not be called as Ssa Congruence Rule since it is not sufficient for congruency. It may take two different triangles. All circles with same radii, all squares with same side length, all equilateral triangles with same side lengths are congruent figures. These are a few more examples of congruent figures. Now we are going to discuss about the similar figures. Two figures having the same shape and not necessarily the same size are called similar figures. These are a few examples of similar figures. All circles, all squares, all equilateral triangles are similar figures. In these examples, we observe the circles are similar and congruent since they are of the same shape and size. But the triangles are similar but not congruent since they are of the same shape but not of the same size. Thus, all congruent figures are similar but the similar figures need not be congruent. Two polygons of the same number of sides are similar if all the corresponding angles are equal and all the corresponding sides are in the same ratio or proportion. Triangle ABC is similar to triangle DEF. All the corresponding angles are equal and all the corresponding sides are in the same ratio or in same proportion. That is, angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F, and also their corresponding sides AB upon DE is equal to BC upon EF is equal to AC upon DF is equal to 1 upon 2. All the corresponding sides are in the same ratio or in same proportion. Hence, the two triangles are similar. In a rectangle and a square, angles are equal and each equal to 90 degree, but their corresponding sides are not in the same ratio. We observe the ratio of the sides GH upon KL is not equal to the ratio HI upon LM. Therefore, rectangle FGHI is not similar to the square JKLM. In a rhombus and a square, all the sides are equal. Hence, their corresponding sides would be in same proportion. But their corresponding angles are not equal. Because in a rhombus, only opposite angles are equal, while in a square, all the angles are equal and each equal to 90 degree. Therefore, a rhombus and a square are not similar. Thus, either of the two conditions is not sufficient for the two polygons to be similar.